Hello, let's have a look at peripherals. We can look at the keyboard, mouse, printer and monitor. Keyboard first. The keyboard works using scan codes. If I hit the keyboard, Q, W, E, R, T and Y, every time I hit a letter I get a different scan code. Now different keyboards will have different codes, but basically it'll be unique to that particular key, uppercase or lowercase or a function. What the system does with it, it has a keyboard controller and it's going to go and temporarily store those, and I need to keep those because I need the processor to go and do some work. So it sends an interrupt to the processor who will say, oh, the user probably ought to prioritise that. I shall stop whatever I'm doing right now and pay attention to it. Which window did that come from? Because obviously if that's a word processor or a different package, that may have a different action need to be due from that. It's going to decide what to do with those letters, because we don't necessarily know that they are Q, W, E, R, T, Y. They could be backspaces. So I'm going to retrieve each of those letters in turn, and in effect I'm going to go and tell the operating system that if this is a backspace, then I need to do take a letter away. If it's a letter and it's on a word processing system, then actually I need to tell the operating system to print that out onto the screen, which for our ones, Q, W, R, T, Y, yeah, that probably makes sense. Okay, so let's have a look at the mouse. The mouse looks for movement between the sort of from the top left hand corner really of the screen. So I've got a huge great mouse pointer here, and it's looking at the X, and the X is across, and we're looking at the Y, Y is down. So every time I'm moving to the right, we can see I've got an X add 1. If I move down, then it says 0 to the X, but I add 1 to the Y. If I then move to the left, I'm no longer adding 1 to the Y, so that becomes 0, but I now need to subtract something from the X. So it's in effect creating these constant kind of view of coordinates. Of course, we've got to decide also what to do if you click on the left or the right mouse button, because that can have a different impact as to what the code which is going to be sent through the system to decide what to do. Okay, the printer. Old printers used to run just a line at a time. So literally it'll send a line and the printer would kind of queue up those lines. But we print sort of enormous great documents nowadays, and that just would be too slow. So we have to use a different method, and we use a thing called a PDL, or Page Description Language. And it takes the thing you want to print and kind of puts it in this kind of wrapper. And this says, right, tells the printer how it needs to be able to kind of manage that, and then the printer will then work that out. It's usually particular to the particular printer maker. They'll have a different one, different type for each one. So you can handle graphics as well, which is obviously quite nice. Okay, so look at the monitor. Look at the monitor in a bit more detail, because actually they're just so smart and the way they work. So we're looking at the flat screen LCD monitor. In fact, if you kind of zoom right into these, each pixel is a little kind of group of 3 little kind of micro pixels, which are set out into RGB, so reds, greens and blues. And what's happening is that it's going, okay, how much light is going to go through to the red, to the green, to the blue? And the combinations of those obviously give you that sort of fantastic richness of colour. Now, it's all worked by using polarised light. So if you've got these two kind of polarised screens, no light gets through. So that's the kind of the normal state. Even though there's a light behind the screen, no light's allowed through within the system. And what there is between these two polarizing filters, there is a liquid crystal. And if there's nothing going through that, no current going through that, then it doesn't change the light at all. So you don't see anything. But if you turn it on, it exactly twists the light by 90 degrees. So it allows the light then to come through that polarized effect, and therefore you can see, well, obviously if it's coming through to a white area, then you see white, but of course you may have these RG or B within there. So by having lots of these throughout the system, by spreading these together, each little combination of the red, green and blue is a pixel, and there from that you get a colour that an effect, because they're so small, comes through just like one particular colour within there. Okay, we're looking at peripherals. Thank you for listening.